Hello there, Mr. Sutton here, bringing you the AB Calculus Chapter 3, Quiz 3 Review Solutions on chain rule, implicit differentiation, tangent lines, and higher order derivatives. On this problem, we're trying to find the derivative of this function. Now, since we have a function inside a function, a composition of functions, we need to use the chain rule. To use the chain rule, we take the derivative of the outer function with the inside unchanged, and then multiply by the derivative of the inner function. So our first step here, we've got something to the 8th power. Derivative of that would be 8 times something to the 7th power. 8 times all this stuff with no change. Now we have to multiply by the derivative of something. Well, the derivative of the stuff inside here, using our power rule, this is going to be 8x to the 3rd minus 15. On this one, we're trying to find the derivative. We're going to use the chain rule. The outer function on here, the way this notation works, is the 5th power. This is really cosine of 4x, all of it raised to the 5th power. So we have something to the 5th. Derivative of that is going to be 5 times something to the 4th. So 5 times cosine 4th of 4x. Now we have to take the derivative of the next function in, which is actually the cosine function. So derivative of cosine of something is negative sine of something, negative sine of 4x in this case. And finally, we need the derivative of 4x itself, the innermost function, which is just 4. And we're multiplying all the links in this chain. To take the derivative of this expression, we're going to use the chain rule. So the outer function here is secant. Derivative of secant of something is going to be secant of something tan of something. So our outer derivative, we've got secant of all this stuff in here times tan of all this stuff in here. Now this is just one big outer derivative. We haven't even used the chain rule yet. But now using the chain rule, we take the derivative of the inner function, which is going to be 15x squared minus 50x, and we're done. For this problem, we're trying to find the derivative of this expression. For that, we're going to need a big chain rule. So the outermost function is cotan. We're doing cotan of all this stuff to the 12th. So the derivative of cotan, that's going to be negative cosecant squared of something. So negative cosecant squared of all this stuff to the 12th. Times, now we have to take the derivative of something to the 12th. Well, the derivative of that would be 12 times the something to the 11th. So 12 times this big parentheses, all raised to the 11th power. And then finally, we need to take the derivative of the innermost function here, this polynomial. So going from left to right with the power rule, that's going to be 42x to the 5th plus 1. And derivative of 19 is just 0, so we can close off that parentheses and call this done. On this problem, we want the derivative of this fraction here. So we're going to have to use the quotient rule on this one, u prime v minus uv prime over v squared. And the game changer on this is we have some compositions of functions, so we're going to need to use our chain rule inside the quotient rule. So let me set up a box and ribbon to organize all this. I have my numerator, all this stuff up here to the 4th power, and my denominator, cosine of x cubed. And now for their derivatives. So for this upper derivative, we have to take the derivative of something to the 4th, which is 4 times this something to the 3rd power. And now the derivative of the inner function, we've got 6x to the 5th minus 9. So that's all one big derivative there. Now we have to take the derivative of cosine of x cubed. So derivative of cosine of something is negative sine of something, negative sine of x cubed in this case, times the derivative of x cubed, which is 3x squared. So let's put it all back together using the ribbon. So a lot of writing to do here, a lot of cutting and pasting. We've got all this stuff in the lower left. That's our u prime. Times cosine of x cubed, that was v, minus x to the 6th minus 9x quantity to the 4th, that was u. And then times all this negative sine of x cubed 3x squared stuff. That was our v prime there. Down below we have v squared. That's going to be cosine of x cubed squared. Or you could be fancy and write cosine squared of x cubed, but there's no need. And since we didn't have to simplify, we're done. On this problem, I'm trying to take the derivative of this product. So I'm going to use the product rule, u prime v plus uv prime. Let me set up a box and ribbon for that. So I have my first factor, 7 minus x to the 6th, and my other factor, square root of all this stuff. Now, since I'm going to have to take the derivative of this, I'm going to rewrite this as 5x to the 4th plus 3x quantity raised to the 1/2 power, just so I can use my power rule a little bit more easily later on. Next, to take these derivatives, I'm going to need the chain rule in both of these cases because I've got some inner functions going on. So here we have the derivative of something to the sixth, which is 6 times the something, 7 minus x to the fifth power. And I also have the inner function here, 7 minus x. The derivative of that is negative 1 because we have this negative x here. So multiply by negative 1. Over here, I've got 1/2 times something to the negative 1/2. Now I have to multiply by the derivative of the something, which is going to be 20x cubed plus, this will be 6x. Putting it back together with the ribbon, I've got this lower left stuff, that's u prime, times all this stuff to the 1/2 power up here, plus we have 7 minus x to the sixth. Actually, that should be a plus there. There we go, because we're using product rule, not quotient rule, so this is always a plus in between here, unless this term itself is negative. So that's getting multiplied by now all the stuff on the lower right that I'm not going to say out loud, so just all that. And we don't have to simplify, so this is done. To take the derivative of this equation here, since I can't easily isolate y, I'm going to have to use implicit differentiation, which basically means I'm just going to take the derivative of everything from left to right, and whenever I take the derivative of y, since y is the output variable, it counts as its own function, I'm going to have to multiply by a dy over dx tail, essentially using the chain rule. So for example, this y to the 7th, I treat this as something to the 7th. So that derivative is going to be 7 times something to the 6th. Now the something is y. What's the derivative of y? Well, it's dy over dx. And again, the key here is that y is the output variable, so I have to treat it as its own function. All right, so next we have, this will be minus 36x to the 8th. 10, derivative is just 0, so we don't have to write that. On the other side of the equation, I have 3 times the tail of dy over dx, and then minus 2x. So now once you've differentiated everything and have all those dy over dx's, we're going to get the dy over dx's on the same side, because we're eventually going to factor out a dy over dx, and then divide by whatever's in the other factor. So this 7y to the 6 dy over dx can stay on the left. I'm going to subtract this 3 dy dx to get it over there. And let's see, I've got a negative 2x that was already on the other side, and also I'm going to add this 36x to the 8th. So add the 36x to the 8th over there, negative 2x can stay where it is. Next, on the left side, I can factor out a dy over dx, leaving me with 7y to the 6 minus 3 inside. And now I'll just divide by 7y to the 6 minus 3 to get it over on the other side, which gives me this final answer. To take the derivative of this equation, I'm going to use implicit differentiation because I can't isolate y. So going from left to right, derivative of 12x is 12. For this negative 3xy cubed stuff, I'm going to have to use the product rule. So let me set up my box and ribbon. I have factors of negative 3x and y cubed, whose derivatives are negative 3. And I need the chain rule on this one because it's a y. So 3y squared times dy over dx, or y prime. Multiplying that out with the ribbon now, I've got minus 3y squared, or 3y cubed rather. And then this is going to be plus negative 3x times 3y squared dy over dx. I'm going to simplify this. So this is going to be minus 9xy squared dy over dx. There we go. And let's see, now we need the derivative of sine of y. It's easy to get lost in all this stuff. So derivative of sine, that's cosine. So we have cosine of y, dy over dx, because again we had an output variable in there. It's its own function. And all that equals the derivative of 10, which is just 0. All right, so let's see here. Let's keep the dy over dx stuff on the left. So negative 9xy squared dy over dx, and cosine, cozy, dy over dx. On the left side, or the right side rather, we're going to subtract the 12 to get it over there, and add the 3y cubed. Now back on the left, I can take out a dy over dx. That leaves me with negative 9x squared plus cosine of y inside that parentheses. Now I'll divide by the stuff in the parentheses to get it over on the right side. And this is going to be my final dy over dx answer over here. To see where this function has a horizontal tangent, we need to basically see where the derivative of this function has a value of 0. So let's go ahead and find f prime using our power rule. We've got 3 times 1/3, that's going to be just a 1 x to the second power, minus 1/2 times 2 just gives us 1 x to the first power, and then this is just going to be minus 6. And we want to know where all of this equals 0. So, as luck would have it, this is a quadratic that we can quickly factor, just thinking of two numbers that multiply to -6 and add up to -1. That would be positive 2 and -3, so we have x plus 2 and x minus 3, or vice versa. And then setting each of these equal to 0 and solving, we have x equals -2 and positive 3. For this problem, we want the equation of a tangent line at the specified point here. So in general, for a tangent line, you need an x value, a y value, and a slope. They actually gave us the x and the y. If they just gave us the x, we could plug it in to get a y value back. We also need the slope, though, so we need to imp diff this thing to get the slope. So from left to right, we have derivative of 6x, which is 6. And this is going to be a product rule, this 9xy. Factors of 9x and y. Derivatives are 9, and dy over dx, we have to imp diff this thing. So using the ribbon to multiply it out, I've got 9y plus 9x dy over dx. Next, derivative of 5y squared, that's going to be 10y times the tail of dy over dx. Again, y is an inner function, equaling the derivative of 4, which is just 0. So dy over dx stuff stays on the left, other stuff moves to the right. We have 9x dy over dx plus 10y dy over dx, and all that's going to equal, we'll move the 6 over by subtracting, so -6 minus 9y. Factor out a dy over dx on the left, that's 9x plus 10y. Dividing by that gives us this expression for dy over dx. Now to get the slope out of this, we actually have to plug in the point 2 comma -1. So here's what that looks like in terms of notation. We have this little bar, xy equals 2 comma -1. So I've got a -6 minus the y value of 9 times, or -6 minus 9 times the y value of -1 in the numerator. Denominator, I've got 9 times the x value of 2 plus 10 times the y value -1. Upstairs, this is going to be -6 plus 9, which is 3. Downstairs, we've got 18 minus 10, which is going to be 8. Yep. And so we have a slope of 3/8. Now, let me use point slope to plug things in. So that's y minus y1 equals m times x minus x1. I have y minus the y value of -1, so y plus 1. That equals my m value, my slope of 3/8, times x minus the x value they gave us of 2. And there's the equation of our tangent line. On this problem, we're trying to find the second derivative of this function. We'll start with the first derivative. From left to right, using the power rule, we have 90x squared minus 18x plus 80. Now for the second derivative, power rule again, we've got 180x minus 18, and the derivative of 80 is just 0, so there's our second derivative. On this problem, we want the third derivative of this function. I'm going to start by rewriting this as 2x to the -3, so that'll be a little easier to differentiate. And now we're just going to take 3 derivatives, one after the other. So our first derivative, we've got -6x to the -4th, and then this will be plus 7 sine of x. Now we'll take another derivative based off of this first derivative. So we have 24x to the -5th plus 7 cosine of x. And finally, the third derivative, that's the derivative of the second derivative. This will be, let's see, -120x to the -6. And then we'll have minus 7 sine of x.